These are 1 over x. So now the question is, how do we graph how do we get the tangent line? Again, to get the tangent line, the way we are going to find the slope of the tangent line first, and then we will get the tangent line. So all we have to do is get the slope, and then we have a point here, and then we'll be able to write the tangent line equation. So 2 comma negative half is somewhere over here. So let me call this 2 and 1, and about 1 is over here. So this point is about 2 and a half, 2 comma half. So this one, let me write, is going to be 2 comma f of 2. So let me write this point. So this point is going to be f of 2 comma f of 2. Let me write it this way. Of course, 2 comma f of 2, f of 2 is half, so it is the point 2 comma half. Again, this point 2 comma half is on the curve. So now in order to find the slope, what do? We need to have another point here, another moving point. Second point must move with. This guy is the fixed point. And now what we want to do is we pick a point here. It doesn't matter. Okay, we can pick a point. You can just pick a point here, and that will be a moving point. So this time I am now going to call this point. Now let's do it differently this time. T comma f of t. I'm going to call it this way. So you can call it 2 plus h comma f of 2 plus h, or the other way of naming this point is called t comma f of t. And again, in this case, on this problem, the letter t is not in use, so therefore we use the letter t. If the letter t is in use, then don't use t. Then use another letter like w or I don't know r, or there's so many letters out there. So use the letters which are not in common use. Obviously, we don't want to use any letter like x or y, but not letters like f or any letter or f. Yeah, we don't want to cannot use letter f. So, like just use some letter, the menu letters. So t. So now, how to get the slope of tangent? The slope of tangent is going to be this. The slope of tangent. So this is the slope of tangent here. So what is slope of tangent? Slope of tangent now is equal to it's going to be the limit. It's going to be limit. And what limit of what? This one, let's see, t approaching 2, yes. T is actually approaching, let me see, do I have an arrow here? Oh, you know what, I don't have a regular arrow here. So t approaching 2. And then what is the slope of the secant line? It's now going to be this. It's going to be f of what? F of t minus f of 2 over, and then t minus 2. So this will be now the slope of the slope of the tangent line. One second. T is approaching 2. So this is now the expression for the slope of the tangent line. Again, this limit right here is not the tangent line itself, but it is the slope of the tangent line. So we're going to find the slope, and then once you find the slope, then we will get the line equation, since we already have a point right here. So this is going to be what? The limit. T approaches 2. And then what is f of t? F of t is going to be what? F of t is going to be 1 over t. And then minus f of 2 is 1 over half, 1 over 2. And then t minus 2. By the way, when you plug in t equals 2 here, as you will see, you will get 0 over 0. So this one, we get a 0 over 0 form. And I will be talking a lot of time. I'll be spending a lot of time on the 0 over 0 form. And so 0 over 0 form, we don't know what this is. Obviously, this is not a regular number. So if you get a 0 over 0, that means you cannot plug in. You have to go back. When you get the 0 over 0, you have to go back. Again, 0 over 0 means cannot substitute, go back. That means cannot sub, go back. That we cannot substitute here. Okay, let me write that in red. Okay. So now let's do this here. How do we do this? How do you evaluate the limit? We want to know what this thing really approaches. So if you actually plug this into your calculator, and then actually look at your graph, and you can actually see where this graph is, how the graph will be near t equals 2. You'll be able to see that. But here we are going to compute this limit without the use of a calculator. So what is this? In this case, we will convert this into a simple fraction first. So the first step is, why don't we multiply both by 2t on top, and then multiply by 2t in the bottom. So where is this 2t coming from? 2t is the lowest common multiple of all the denominators. So we have t and 2, and then within the denominator, there is no denominator. So in this case, we just take the lowest common multiple of all the denominators. That will be t and 2. So the lowest common denominator of all the denominators will be 2t. So that's where it gets to 2. So we are basically simplifying this expression right here. So to convert that into a simple fraction, because right now we have a complex fraction, we multiply top and the bottom by 2t. So if we do that, so let's see what happens here. Then this is going to be now the limit. And then now t is approaching 2. You know what? Maybe I'll change the color to black. Since, okay, and then this. And then the denominator will be 2 minus t. Is it going to be 2 minus t? Yeah, it is going to be 2 minus t. So let me write this as minus, and then parenthesis t minus 2. So I just factor the minus sign. I just want to save one step. But if you multiply out the denominator, we get what? Sorry, and that is wrong. That should be the numerator. Why am I writing it here? Okay. The denominator is 2t is going to be 2t times t minus 2. That will be the denominator. We'll write it on that. The numerator will be what? Will be 2 minus t, which is minus the t minus 2. We'll get this. So we get that. And then as I said before, when you say that t is approaching 2, when t is approaching 2, what that means is that t is not 2. Again, when you say t is approaching 2, then that means t is not 2. Again, when t is equal to 2, then this point and that point become the same. If you don't get a line, the entire argument breaks down. So we assume that t is not 2. Obviously. So we need 2 points. So t is not 2, or that's the moving point. So we get that. And so now what we do is we are going to now reduce this t minus 2 and this t minus 2. And so when you reduce that, and now what we get? Now we get minus 1 over 2t, and t is approaching 2. The final result is that we get y is equal to negative 2. So that is now the final answer to the question. Again, reduce the x minus 2 at x. Reduce the t minus 1 to t minus 2. But when you do that, you're left with minus over 2t, and t is approaching 2 now. Note that t is approaching 2. So when you now plug it in, we do get negative 1 over 2. And so we get the final equation. So what is the last equation? The last equation will be now y minus a half. So the slope is negative 2, and the point is 2 comma half. So right here. So that will be minus 1 over x. 1 over x
I'm confused on how you find the limits. Because because
this is going to be y plus negative 1 over x. By the way, we will have plenty of time to do the limit, okay? So, you know what? If you're not, we if you're not, if you have one question about the limit here, don't worry. The next 2 hours we'll be talking about that limit. That will be the rest of it. Okay, so 1 second. So let me just write down the equation here. -1 for that. And if you multiply this out, we get plus half. And then we add half to both sides, we get another half. So we actually get this. You get y is equal to -1 for x plus 1. And so if you look at the graph here and try to get the line equation like this, then you can see that looks like the line has about slope -1/4. They kind of make sense. Okay, so now what is your question? Your limit is your question. What is your question here?
Yeah, what's the limit for? Why is the, for example, 3 the limit is 2, but for example 2 the limit is 0?
That's because in example 2, I let the fixed point here. So now let me mark this in red now. This point right here, this is the fixed point, is 2 comma f of 2. And then now we have to, in order to find the slope of a tangent line, first we need to find, we need to mark another point on the curve. And so in this case, the other point, we marked it this way. We marked it as 2 plus h comma f of 2 plus h. Or 2 plus h comma f of 2 plus h. So it doesn't matter where you put it, but it's going to, it will cover both cases. So in this case, h could be positive or h could be negative. So let's say this is now the moving point. Now, in order to get the slope of the tangent line, what must happen is this moving point right here must approach this point right here, so that the 2 points would eventually be here and next to each other, very close, like this. Because if you have 2 points here and there, if you have a point here and a point here, that will never be the slope of the tangent line. So what you have to do is we pick this point here, and this guy is fixed, and the other point is a moving point. This guy must move along the curve and then approach the other point. Now, if you look at this 2 plus h comma f of 2 plus h, and this is 2 comma f of 2, we want to let this point right here approach 2 comma f of 2. Now look at the x coordinate. Just look at the x coordinate of both points. This point, the x coordinate is 2 plus h. And now what is the x coordinate of the fixed point? Is 2. So this is 2, and this is 2 plus h. So how do we let this moving point approach the fixed point? And that must be h must approach 0. Because 2 plus h right here, oops, what did I do? Did I lose the
You can't see your screen anymore.
Oops. What happened here? Did I lose my whiteboard? Oh no. I don't know what I put in. It looks like I didn't save it. I lost that entire picture. So basically basically this is what it is. So we have a point here. We have this.
Wait, Professor, what program are you using? You might be able to undo erasing the whiteboard.
Erasing the whiteboard?
If you erased it, if you're on Windows, you could probably just do Control Z to undo that.
Right, but you know what? I never saved it. So when I tried to undo it, the first screen, the midterm is tomorrow, that screen shows up. So somehow I lost it, I never saved it. So I don't know where it is. Again, I'm not sure. I don't think I made a mistake here, but sometimes, my screen, my computer does these kind of things. But you know what? Let me just explain to you. Sorry, that screen is not saved. So now basically let me just call this, just do this here. This point was called 2 comma f of 2. And the other point was called, so all you have to know is this point. All you have to know is that this point right here is now called, I call this point 2 plus h and comma f of 2 plus h. Actually, I think this is good because now everything is clean here. Okay, so we have this. And then now, if you want to let this point, basically our idea is we want to let this point right here move towards this point. And so if you want to do that, then 2 plus h must approach 2. So what should h be? H should approach 0. point is that this point right here, we want this point to be really moved too close to this point so that this point right here is not here. We really want the point to be next to right here. That's what we want. This is what we want right here. We actually really want, in order to find the slope of the tangent line, we want the 2 points to be next to each other. But on a graph, there is no point which is next to that fixed point. There is no such point because there's always a closer point. But we get this, so h is equal to 0. But now, if you let this other point be the point T2, let's say, let me write this way. So let me call this guy, T comma f of t. So T comma f of t. If you now call it this way, if you let the moving point be T comma f of t, then how do we let this T, how do you let this here, this point right here, T comma f of t, so how do we let this point T comma f of t approach this point 2 comma f of 2? How do you do that? How do you let this point approach this? Now just look at the exponent. This T must approach 2. So in this case, the T, we want to know what happens as T is approaching what? So do you understand the limit here? That's why this is T is approaching 2. And if you write it this way, 2 plus h comma f of 2 plus h, the h is actually the difference in exponent between the 2 points. So now what you want, we need the limit h is approaching 0. But it's not that h is always approaching 0, nor is t approaching 2. T could approach 0 and h could approach 2. H could approach 5, h could approach 6. Doesn't matter how, so we have a lot of ways of saying it. Now, the same point out here, let's say this is a moving point. How about if I name this point, let's say, for example, if I name this point, let's say, how about if I name this point w plus 5, comma, f of, let's say, w plus 5. What happens if I name that point, if I name this point w plus 5, comma, f of w plus 5, and the fixed point is still 2, comma, f of 2, then what should this w approach in order to get the slope of the tangent line? Can you guess? If I name the moving point be w plus 5, comma, f of w plus 5, then what should this w approach in order to get the slope of the tangent line? Can you tell me?
3.
Find the fish. Find the slope of tangent. Slope of tangent. W has to approach what? W has to approach what in this case?
Negative 3.
W has to approach negative 3, exactly. Because right now the whole point is this. Again, whole point is this right here. The whole point is that this, basically the fixed point is this right here. It's 2 comma f2. And this is the half point right there. And if you want the moving point, this point right here, to be this guy right here, if you call it this guy, w plus 5 comma f of w plus 5. Now obviously there is no reason in this case to name it that way, but you can, of course, it's correct. But again, we will not do it that way here. But so now in this case, if you want to let this point approach that point, then t w plus 5 must approach 2. So just look at the exponent. And then as you can see, w must become negative 3. So we have to let this w approach negative 3. Now, if w is equal to negative 3, that is not allowed. Because if you let w is equal to negative 3, then we actually get the same point. And we don't get the line, we don't get a line, and therefore we get no slope. In order to find the slope, we must have 2 different points. So in this case, the tricky part is w is not 3 and not negative 3, but we have to let this w approach negative 3. So that's the whole idea. So if you now let this point right here, if you let this point be 2 plus h, comma f 2 plus h, and the fixed point is always 2, comma f 2 in this case, then now what is this? Now we want to let this 2 plus h approach 2. So in this case, h must approach 0. That's why you have h approach 0. If you let the second moving point be what? Be t comma f of t. Now let me call this blue. If you call this guy f t comma f of t, then of course the t must approach 2. So in this case, t must approach 2. Okay, any questions here? So the whole point is the moving point must approach become 1 point, because if you only have 1 point, then we don't get a line. And so we don't get a slope. Cannot get the slope. In order to get the slope of the tangent line, we must get a line. That means we need 2 distinct points. But we want the difference of the two points to be really close. And basically, we want to let that approach 0. So we want to see what happens if, as that point is approaching that fixed point. We want to see what happens numerically. And whatever it approaches, that number is actually the slope of the tangent line exactly. Because that line is a target line, it is approaching that line, and if you look at the numbers are also approaching that number. So we are equating the number and the line. The both are not reachable, both are not zero. We never get the line, we never get the tangent line, no matter which 2 points you pick, and we never get that number either. But when you equate the target of the line and target of the algebra, then they will have to match. So the limit is actually exactly equal to the what is equal to the. Okay, so let me save here. So what I'm going to now is I'm going to go back here. No, this is the same. Okay, so that was example 1 and 2 and 3. So now this time I'm going to now speed up a little bit here. By the way, I did write the solution to example 4, so I don't have to spend too much time because they have a lot of writing here. This example 4 is actually an example from mechanics and physics. So if you take the first course in physics, then you will actually take the course, you'll deal problems like this. So let's look at this example 4. In example 4, we'll be talking about the concept of instantaneous velocity. Instantaneous velocity. We have 2 kinds of velocity. We have instantaneous velocity and we have average velocity. Now, first, before we begin, let me go over the basics of this. Oops. Where's my Zoom? Okay, here. Okay, so no. I'm trying to get my writing here. Where is that? Okay, so where's my writing? No. Wait a minute. Where's my annotation here? I lost my annotation. That's not what it is. There. Share screen. Oh, yeah, share screen. I see. This share screen. Now I see it. I don't see. Okay, I get it now. All right. So I'm back here. So this is section 1.4 notes, and now I would like to discuss section of example 4. Okay. Oops. Where's my annotating again? Okay, there we go. Sorry. Okay, so we have this. So let's look at example 4. Example 4. So it's the find this. So we have this. Everybody knows the formula R equals C. Rate times time equals distance. Basically, rate. In this case, what we want is this. We want the speed. What is the speed? Speed is equal to speed times what? Time is equal to what? Is equal to the distance. Okay, everybody knows this very simple formula, right? Because now here we want velocity. Now what is the velocity? The velocity is like speed with direction. So let me write this down. What is velocity? With the velocity. Velocity is equal to what? Is equal to speed with direction. But anyway, in this case, we don't have that much direction. because the object will be moving in a vertical line. Okay, so let's see what the question is. The question is, so the question is, from a height of 400 feet, an object is released freely to the ground with zero initial velocity. S of t is equal to negative 16t squared. S of t is equal to negative 16t squared plus 400 represents the height of the object at t seconds after the release. So now let me explain to you what this S of t is. This S of t is what we call the position function. So what we have is this. What we have is, let me explain to you. So the question, what is the question? I'm trying to help you. I want everybody to understand what the question is. So let's say this is the Earth. So this is the Earth. So this is the ground. Okay? So let me just call this the ground. And then I'm going to write the x-axis, the s-axis this way. So let me now create s-axis. S-axis is over here. This is the s-axis. And then s, and let's say this is now 400. And s equals 400 is over here. That means it is height of 400. That's the position. And then the ground will be s is equal to 0, of course. And now what is s of t? S of t represents the height of the object at t seconds after release. So what happens is, what is 0? What is s at 0? S at 0 is 400. So what is s at 0? This is 400 here. Is s at 0. This is the position of object at t equals 0. At t equals 0 seconds. At t equals 0 seconds, let's say there's a stone. A stone is at the height of 400 feet above the ground. This is feet, by the way, 400 feet above the ground. So that's where it is. And then at t equals 0, what happens is the stone gets released. And so now at t equals 0, where's the stone? The stone is over here. So that's where the stone is. And then now what happens to the object? Where is the object when t equals 1? So when t equals 1, the object is over here. Over here somewhere. And then when t equals 2, the object is here somewhere. It is obviously not in scale. So now the question is, what happens when t equals 1? When t is equal to 1 second, by the way, 1 second. What is s of 1? S of 1 is over here. What is s of 1? S of 1 is equal to, when you plug in t equals 1 into the function f, then we get s at t equals 1. So you get minus 16 plus 400. So we end up getting 384. 384 feet. We get this, 84 feet. And this is actually 1 second. So let me just write 1 second here. This is 1 second. Okay? So what does this s of t represent? S of t represents the height of a function at t seconds after the release. When t equals 0, when time t equals 0 seconds, the object is at 400 feet. And then when t equals 1, then the object actually comes down. It's falling towards the ground at t equals 1 second. S of 1 is the position of the object at t equals 1 second, and that would be 384 feet. And now, what happens? Where is the object when t equals 2 seconds? So in this case, when t equals 2 seconds, what is that? What is that? S of t. This is now the position of the object at 2 seconds. And so if you do that, then we get minus 16 t squared. T squared is 4. T is 2. So we end up getting minus 64. So there's not much space there. So I'm just going to the calculation. Minus 64 plus what? Plus 300, 400. So what will that be? That will be plus 336. So we end up getting 36 feet. So when you plug in t equals 2 into the function here, that will be what? That will become 336. Yeah. So obviously this is not in scale. And then the stone, the object is falling down. Now we want to know. Okay, everybody, does everybody understand the question here? Class, does everybody understand the question? Class, does everybody understand the question?
Yes.
Yeah. Okay. So now let's see. Again, here I'm trying to help you understand the question. So now we have 4 parts here. A, find the average velocity of the object from t equals 0 to t equals 2 seconds. So now this is t equals 2 and 0 and t equals 0. This is actually t equals 0. And we want to know what happens, how fast this object is moving from t equals 0 to t equals 2. So from t equals 2, from t equals 0 to t equals 2, how much is it moving? So here we are asking about the average velocity. An average velocity. Now rt equals t. So what is r? Or the speed in this case. The speed is going to be distance divided by time. And so we can actually get this. It is basically the average velocity will be distance and time. And so what is distance? The distance is actually change in position over change in time. By the way, in time, there are 2 kinds of time. We have t and we have delta t. Delta t, or we can use small t. T and delta t. There's a difference here. Again, in English, they both call time. But t is what I call the absolute time. Absolute time. And this t, delta t, is called the duration, time duration. There's a difference here. Again, t. So what is t? If t equals 2, that means 2 seconds. It means it is referring to 2 seconds. That's fine. It's like, when did you go to sleep last night? And then you tell me, oh, I went to sleep at 10 o'clock last night. The 10 o'clock is what? 10 o'clock is what? Is absolute time. That's absolute time. So went to sleep at 10 o'clock, that's absolute time. That's one time in a point. That's the one time in the time axis. So if I ask you, how long did you sleep last night? And then you tell me, oh, I slept 7 hours last night. Then that 7 hours is really the difference in absolute time. You slept from, let's say, 11 a.m., 11 p.m. till 6 a.m. Then that is 7 hours. And so that will be called time duration. So that average velocity is really what that is, from t equals 2 to t equals 0. And in this case, that will be what? Delta S, change in position over change in time. And then now if you look at part B, by the way, part B, what is that? Part B, find the average velocity of the object from t equals 2 to t equals 3. So this one is also delta t over delta S. It will actually be this right here. And then after that, we'll be talking about the instantaneous velocity, okay? And we only find the instantaneous velocity at t equals 2 seconds, and the other one has instantaneous velocity at 3 seconds. So I'm going to talk about that. So what I'm going to do is, I'm going to save this, and now I have prepared a file. I have prepared a solution file to this example right here. So what I'm going to do is, I'm going to save this, and then I'm going to clear all this, and I'm going to now open up the next one, which is tangent example 4. So that which is this one here. Okay, I wrote this last night. So hoping to save some time. Okay, so this is what it is. Am I sharing this page? Yes, I'm sharing this page. And so we now have this. So this is now section 1.4, example 4. That is exactly the problem which we are doing right now. And so let's do it. Okay, so now let's look at this. Let's look at part A. Let's look at part A. So part A is what is the average velocity of the object. V1 average velocity from t equals 2 t equals 0 to t equals 2. 2 seconds. What is the average velocity of this? And by the way, I wrote down V here. Usually they actually put a bar here. If we take the physics class, average anything, usually they put a bar. Not always. but many times they do. So the notation could be a little bit different. So this is now this is what they're asking. This is the notation for the average velocity of the object from t equals 0 to t equals 2 seconds. That's the notation we use here. So v bar from 0 to, on the interval 0 to 2. So from 0, f t equals 0 to t equals 2 seconds. So what is the average velocity? The average velocity is the change in position over change in time. So this will be the position at 2 seconds minus the position at 0 seconds. And then the p-value is 2 to 0, so it's 2 minus 0. So basically, the idea is we have t comma, and then s of t. We have time versus what? The position. And now we want to take we are now going to consider 2 points. The first point is 0 comma, s at 0. Okay, you know what? Let me type this. I think we'll be a little bit faster. So here, we are going to consider this point, 0 comma f, 0 comma f at 0. So this includes the time and the position. And the second point is going to be 2 comma s at 2. Okay? So this is the first point is t, the second point is s. And so what is the velocity? The velocity is change in position over change in time. So we have 2 points here. So what is the velocity between those 2 times? We take the difference in position over the difference in time in the same direction. So s of 2 minus s of 0 over 2 minus 0. And so when you actually calculate that, that's what you get. S of 2 is equal to minus 16 times 2 squared plus 400. And then minus what is s at 0 is 400. And so over 2. And so we now get minus 32. So the velocity is actually minus 32. Why is it minus? What's the meaning of this minus here? And that's because it's minus because, again, when I drew on the other graph, this was the ground. This is the ground. And what is the height? That's the ground. And then the height is, and then we have the s-axis this way. And s of 400 was right here. This is s equals 400. And the bottom right here is this is s equals 0. This is s equals 0 is over here. And we have an object right here. And we are letting this object go this way. Now this is the positive x-axis. So if it's going down, what does that mean? That means x is actually going down. It's negative. So in this case, the velocity meaning the object is actually moving in the x minus direction. Because if it goes up, then velocity should. If the velocity is positive, if it goes down, then the velocity is negative. V is negative, and then if you go up, V is positive. So in physics, we don't go by speed. We actually go by velocity. So velocity is basically speed with direction. So if the v is positive, then it moves in the positive direction, positive axis. And if v is negative, then it's going to move in the negative direction of the positive axis. Now in this case, that is because we decided this to be the s plus. But we can make the s-axis this way. If you make the s-axis this way, then of course s plus axis downward. In this case, going down means v is positive, and then going up means v is negative. So whether it's positive or negative depends on how the axis is set up. Anyway, more about this later, but I think we'll more about this, revisit this topic when we get to, I think, chapter 4, I think. Okay, we'll get there again. Kind of type of problem. This is a free fall. Okay, so we get 10 and then we get minus 32 feet per second. So what that means is, in average, what does it do? From t equals 0 to t equals 2, it is moving minus 32 feet. In fact, we do get, this is at 400 here, and then at t equals 0, and the point is actually right here, when t equals 2, you know what that was? You know what s was? S was 336, we got that. S is actually 336. And so, from t equals 0, this is when t equals 0. From t equals 0 to S t equals 2, how did the S change? S actually went down by 64. That is, change in S is minus 64. And then that was in 2 seconds. So in average, how much did it move per second? The position moved by minus 32 per second. So that's what we call the average velocity. Average velocity. The position changed by minus 32 per second. Because 400 to 336, it actually changed minus what? Minus 64. And so that was 2 seconds. Therefore, the average velocity is minus 32. That's what it is. Okay, now let's do part B, very similar. In part B, we now want the average velocity of the object from t equals 2 to t equals 3 seconds. So now, what is this? Now we're trying to get this guy. Okay? The same thing. S of t, S of 3 minus S of 2 over 3 minus 2, and then I'll do the rest of it, and you get my minus 80 beats per second. Okay? So from t equals 2 to t equals 3, what happens? The change in position is actually minus 80. Within that 1 second, the position changed by minus 80, meaning that the object went down. Minus 80 minus means that the S value went down. That means the object went down towards the ground. Because in this case, S plus axis is constant. So minus 80 means it's actually in the downward direction. So that's the average velocity. Any questions here? Okay, now let's look at example 4, part C. Part C. Find the instantaneous velocity of the object at t equals 2 seconds. Equals 2 seconds now. Now, we want the average, and we now want the instantaneous velocity. Now, what is that? So we want to find the velocity at t equals 2 seconds, not from t equals 2 to t equals 3, or t equals 2 to t equals 5. But we want the instantaneous velocity at t equals 2 at that one point. So the object is so here is here, and here is the object, and the object is actually coming down here. T equals 1 here, t equals 2 here, and then t equals 3 here, and the object is actually coming down. But now this is at t equals 3. So now the question is at t equals 3 seconds. T equals 2 seconds is actually here. The question is what? The question is, at that point, t equals 2, how fast is it going at that instant? How fast? How fast at 2 t equals 2 seconds? How fast? So at that instant, at t equals 2 seconds, how fast is this object moving? So that's the question. This is the question of instantaneous velocity. Now, if we pick t equals 2 and t equals 3 like this, if it's t equals 2 and t equals 3, you know what? This will be average velocity. We're not going to get instantaneous velocity. How about if we select t equals 2 and then select, and then what? Select t equals what? 2.1. Will that become instantaneous velocity? If we pick these 2 points and get the speed, velocity, then do you think we can get the instantaneous velocity? No, because the difference in t is still 0.1. The 0.1 difference is not good. The difference should really become almost 0. Should be 0, really. So in this case, we now apply the very similar concept. In this case, we are now going to take the average velocity from, not from 2 to 3, not from 2 to 2.1, but from 2, t equals 2 to t equals 2 plus h. You now get this. And then in order, so this guy right here is the average velocity from t equals 2 to t equals 2 plus h. Now we want the instantaneous velocity. Instantaneous velocity, we write it this way. What is the velocity at 2? And we don't put a bar here. So what is the instantaneous velocity at t equals 2? Well, we have to take the average velocity from 2 to 2 plus h. And then in order to calculate the instantaneous velocity, what do you do? Well, this interval we don't want from 2 to 2 plus h. We want this gap to go to 0. So now we want this h approach what? H approach 0. Because we have really what? We have basically what? Basically t. We have t equals 2. So we don't want 3. So we want this 2 plus h. But even 2 plus h is not too close. So in order for this 2 plus h to get close to t equals 2, what must happen? H must approach 0. So that the time gap will be almost 0. So 2 to 2 plus h, that's average velocity. But average velocity will not do. We want instantaneous velocity. So we now have to let this h approach 0. So we now take the limit. And this is the average velocity from 2 to 2 plus h. Close the gap. You now let this h approach 0. A very similar concept to what we have seen on example 1, 2, 3. Anybody has a question here? By the way, when you plug in h equals 0 here, when you plug in h equals 0 here directly, you know what we get? We get this 0 over 0 again. So when you get this 0 over 0, what does it mean? That means you have to go back. You have to go back. Go back. This means what?
Go back.
And go back. That means you cannot substitute. That's what it means. Because 0 over 0, we don't know exactly what that is. It's not a number. It's not like 2 over 5. Anyway, we'll get to that right now. But right now, if you get 0 over 0, that means you cannot substitute at that point. We somehow have to change the form. We don't see where this expression is heading to. Now, if you actually punch this into a calculator or graphic calculus, you will be able to actually see the rough answer because you can kind of see. So when h is equal to 0.00001, then I will see it on the graph. Yes, you will. So if you actually plug this into a graphic calculator, you will be able to see what happens when h is getting close to 0. You will actually see the answer almost. But you will not be able to pinpoint exactly what the number is. You'll get that in number in decimal, and that will not be acceptable, okay? So you have to evaluate this mathematically. Okay, so now you do all the rest of it, and then and the rest of it is straightforward, and then at the end, you do get minus 64. So minus 64 turns out to be the instantaneous velocity at 2 seconds. So at that instant, at t equals 2, how fast is the object moving? It is instantaneously moving at instantaneous velocity minus 64. That means it is heading down. Obviously, everything is heading down here. So I'm going to save the picture, screenshot, and now let me clear all this. Now I'm going to scroll this down. Now let's look at S2. Now C2. So what is C2? C2 is the same problem. We are doing C here. We are doing C, but this time I named it differently. So in this case, what did I do? Instead of the velocity from t equals 2 to t equals 2 plus h, instead of this, how did I name this? I named the interval from the interval from t equals v, the velocity, average velocity, from t equals 2 to t equals w.
So maybe tell me these are wrong.
You cold?
T equals
No,
2.
if you are, I'm saying.
No, I'm not.
And then here's the object at t equals w.
7 was sleeping under the covers with you.
Instead of 2
He
plus
was
h,
under the covers.
I named it
He
w.
was scared.
Now, if you want to find the slope of the tangent line, what do we need to do? We have to let this t equals w2 and this other point be very close to t equals 2. So
9,
in order
12.
to get the slope of, in order to get the instantaneous
You gotta do
velocity,
what?
which is like finding the slope of the
What time?
tangent line, what we have to do. So in this case, what do we want? What we want is what do you want? We want W approach what? We want this W approach what? 2. Because so that the gap will be very, very close.
He's looking out the
Basically,
window.
T equals 2 to T equals 2.00001. But that's not good enough. So we want the gap to to be from t equals 2 to t equals 2.0000001. And we want to do that forever. So we cannot do that forever. So we now take the
That's
limit.
amazing.
We want this t up for double approach too. So the velocity from t equals 2 to t, so from t equals 2 to t equals w, we get this. So we get this is now the average velocity. Now we want to close the gap. We want to take the limit for t approach 2. And when you do that, that limit expression, the final result will be the instantaneous velocity. Now, C1 and C2, they're exactly the same problem. Same problem. Here I wrote 2 to 2 plus h. Here I wrote 2 to w. Exactly the same. But initially, you're not used to these kind of variations here, so I wrote both variations. Now, if I ask you a question like this, you only have to do one way, not both ways. They're all the same. Very similar, okay? So you're not required to do this in two ways. Just one way is good enough. So if you now compute the rest of it, the rest of it looks like this. And yeah, you can barely see the bottom answer is minus 64 at the end. It is the same problem. The notation has a tiny difference, that's all. So let me just save this and clear this. Anyone has a question? And now, this time, now let's move on to D. Now what is D? Is now what? The instantaneous velocity at 3 seconds. So when you want to find the instantaneous velocity at 3 seconds, then this is now we take the average velocity from t equals 3 to w. Instead of 3 plus h, I use w. I'm plotting the format of C2 instead of C1. So you can do either way. But right now in this...
Hey, get off the computer.
Every problem, but this is what I recommend. Apply different methods on different problems. For one problem, use one notation, and the next problem, use the other notation. That's what I want you to do, okay? And then if you do that, then again, the same thing here, and then you get minus 96 at the end. And that is the instantaneous velocity at t equals 3 seconds. Any questions here? Any questions? Okay, time is ticking. Any questions here? I wrote everything in absolute detail so that everybody will be able to follow me. Normally, I would skip some steps, but in this case, I did not skip any steps. Okay, so yeah, I wrote down every single step so that every step is clear. Every step is immediately clear. All right. So okay. All right. So that is DA1. Now, what I want you to do is, you know what? If you want some practice, this is what I want you to do. Instead of the average velocity from 3 to w, t equals 3 to 3 plus w, why don't you try to take the average velocity from 3 to 3 plus h. And then that will be a good exercise. So why don't you do this? Okay, h, and then take the limit. H is approaching 0. The limit, h is approaching 0. And if you do that, of course, you should get the same answer. The final answer should be minus 96, just like this guy. Because they have the same problem. Okay? So why don't you try this, and you should get the same answer. You can check. Okay? All right. So let me now stop this. So save. Okay, I'm going to clear this, and now I'm going to let's go back to now section 1.4. 1.4 and 1.5. By the way, there was a mix-up between 0715A and 0715B. So last night I had to rename it. So if you printed like more than 10 hours ago, okay, then you might have the two files interchanged. Okay, so one file is 0715A and the other one is 0715B. So let me open up 0715A. Section 1.5, the first one is this one. Evaluate limits. So now on this section, we are now going to follow. Let me see. Are we? Yeah, we are. I'm showing this page. So now we get this. So now what we have is In section 1.5, we have this. Okay, section 1 for the evaluate limits. How do you do this? Example 1, limit. A limit x squared, limit x squared minus 4 over x minus 2 when x is approaching 2. So this, we read this as the limit of x squared minus 4 over x minus 2 as x is approaching 2. That's how we read it. Okay, I'm going to read the limit many times. And this x squared minus 4 over x minus 2, that is what we call the argument of the limit. So we have the limit of this as x is approaching 2. Now, x is approaching 2 here, what happens if we plug in x equals 2? X equals 2, then the expression,
0.
then what? Then the limit actually becomes what? The limit of this guy, what does it become? It becomes 0 over 0. Oh, 0 over 0? Now 0 over 0 is a problem. What is this? Well, I will be spending time on this, a lot of time on this kind of form. And this 0 over 0 is what will be known as an indeterminate form. And then indeterminate form. Indeterminate, what does it exactly mean? Indeterminate form, what does it exactly mean? This means that don't know the answer yet. Don't know the answer. What does it mean? It really means to work harder. Problem is not over. Not over. And let me make this important comment. Indeterminate form is never an answer to any problem. Alright? So let me write this in red. Indeterminate form is never answered in an indeterminate form such as 0 over 0. 0 over 0 is an indeterminate form. And I already talked about indeterminate form, so just hold. Okay? Just hold on. Don't ask me too many questions. And all of these guys are coming up. Indeterminate form is never an answer to any problem. And the first kind of indeterminate form we see is 0 over 0. So when you get 0 over 0, that means we have to go back. Indeterminate form, don't know the answer. It also means go back. Also means go back. And I will talk about this form. So now in this case, that means we cannot figure out the value of this limit. We don't know where this is heading to. But if you actually use your calculator, you can, or graphing calculator, you can figure out what's going on here. So now this time, let's now change the form. So this is now the limit. Again, when you say limit x is approaching 2, we mean x is not 2. We just want to see what this guy's heading to. We want to know the target value of this argument as we have this limit. So now, what is this going to be? X squared minus 4. Now, the first technique of evaluate limits for polynomials and rational functions, it is actually factoring. The factoring is the first technique. And then we get this. So it is still 0 over 0. Now, you have the limit here. Now it says that x is not 0. So what can you do? We can reduce that x minus 2 on top and the bottom. So therefore, what do you get? We now get x plus 2. And then now, it is not an indeterminate form anymore. We don't get 0 over 0. When you actually plug it in, why did our x approaching 0? It should be x approaching 2. X approaching 2. Okay, x approaching 2 should be x is approaching. X is approaching 2. X is approaching 2. So this will be now what? 2 plus 2. 2 plus 2. X is approaching 2. Now we plug in here and we write the equal sign. The answer is 4. What that means is this guy right here, as x is getting closer and closer to 2, what happens to this argument of the limit? This argument of the limit is actually getting indefinitely. It is getting closer to, so close. It never reaches there. But then x is never reaching 2 either. X is never 2, and the argument is never 4. But then, therefore, if this x is approaching 2, then that argument is approaching 2. So we are equating the two targets. The languages, we say the limit is. We don't say this is approaching 4, we say the limit is 4. Any questions here? Okay, so now let's look at example 2. Very similar. Example 2, once again. So the first thing is t is approaching 0. So what happens when you substitute equals x equals 0 and x equals 1 here? If you substitute x equals 1, what do you think we get? The first thing is always to plug in the value and then see what happens. So x is approaching 1. Okay, so what happens if x equals 0 and x equals 1? Should it
I'm missing no spray. Did you see it?
No, you're not missing it.
I looked at it.
Huh?
I bet that 7 was put in there. It's not. 7 was put in there. 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 7
No answer. No answer is not the same as not knowing the answer. Is that clear? So is it no answer or you don't know the answer? If you don't know the answer, that's what we call an indeterminate form. If you know the answer, then and it could be undefined. Undefined is the final answer, if that's the final answer. But indeterminate form is not the same as undefined. Okay? So that's not the same. You have to be careful there. Okay, so now we get that. Okay, now example 3, let's look at it. Example 3, we have now a quadratic over cubic of 0 over 0 form. When you plug in, again, x equals -1, you do get 0. So we have 1 minus 4 plus 3 is 0. When you plug in -1 into the denominator, we get -1 plus 3 minus 2, we also get 0 over 0. Hence, cannot plug it in. So now we have to what? We now have to substitute again. We have to now change the form. The first technique we want, the first technique for evaluating limits for polynomials and rational functions is what? Is by factoring. So in this case, looks like when you plug in 0 there, we get 0. So that means the numerator has a factor x plus 1. We know that there's x plus 1 there. Why? Because when you plug in x equals -1, we get a 0. So now what's the other guy? The other guy is x plus 3. Oh, that's the giveaway, right? There we go. Everybody, you get that? Everybody, do you follow me here?
Yeah, that
Yes.
makes sense. Oh, I also have a question.
Yeah, what is the question?
Will a lot of the answers be in fraction form?
Yeah, fraction. Fraction form is the way to go.
Okay.
Because now, so decimal. By the way, you can actually use a calculator to get the answer. But again, if you use the graphing calculator, you will get the answer in decimal. And when you get in decimal, many times the decimal you get is not an exact decimal, but you will get an approximate decimal, such as like 0.142. And now you don't know what this 142 is. The actual number might be 1 over 7. And then on the graphing calculator, it might say 0.142 or 0.143. Or maybe one more digit, 0.1429. But whatever you get, the decimal you see on the graphing calculator is always an approximate decimal, which I'm not going to accept. That graphing calculator is a great way to check your answer. That, there's no problem, okay? But don't use a graphing calculator here, because your graphing calculator will always give you an approximate decimal, which I will not accept in this case. Okay? So now if you look at the denominator, we plug in -1, we get a 0. That means the denominator also has a factor x plus 1. But now, we don't know what the other guy will be. So how do you find the other guy? How can you find the other factor in the denominator? Now this is cubic. Divide x plus 1. So in this case, we know that there is no remainder because when you plug in, we get 0. And so in this case, why don't we just apply the synthetic division? Yeah, synthetic division is popping up here right here. Okay, chapter 1, synthetic division is popping up. 1, 3, and then note that 0 minus 2. Don't forget to put
Because everybody's trying to get tested.
the 0 there. And then
I'm just gonna go to campus.
plus 1.
I get a free one.
We have to put -1.
Smart. Thank you.
But are you happy to see synthetic division here?
Kind of, yes.
Do you need to know synthetic division in chapter 1 to do
Yes.
calculus? Yes, you do.
Yeah, definitely.
That's why I spend a lot of time on all the prerequisite skills. It's popping up now. Factoring, you have unit that too. And square roots, conjugates, all that, popping up. Yeah. Okay, so we get this. So now what is this? -1. Oh, sorry, not minus, it's 1. 1, -1, and then 2, and then -2, and then -2, and then 2, and then 0. Oh, that is going to be the remainder.
Almost fell off the bed.
So now this is going to be x plus 1 times the quotient is x what? X squared, and then what? Plus 2x, and then -2. Now note that in this case, when you factor this, this is easier than factoring. Why? Because we already know that we have x plus 1. How do you know that there's x plus 1 in here? Because when you plug in x plus negative 1 in here, you get a 0 over 0. And so in this case, you get a 0 denominator. That means this guy, when you plug in negative 1, x plus negative 1, you get a 0. So you already know that there's a factor x plus 1. So it's actually easier than factoring. It's factoring, but they already give you what the factor, one of the factor is. So it's actually easier. Okay, so now when you plug in x plus negative 1 here, you still get 0 over 0, so you cannot plug it in. So now in this case, what do you do? So now we have x plus 1, x plus 1, and x plus 1. So that guy, those factors will get reduced. X approaching negative 1. Once again, x approaching negative 1 means x is not negative 1. X is not negative 1. So now we can reduce those guys. X plus 1. So now if you do that, then what do we get? We get x plus 3 over what? Over x squared. Over x squared. And then plus 2x. Plus 2x. And then minus 2. And now, let's see. Can we now substitute x plus negative 1 in here? If we do that, what do we get? We do get a negative 1 plus 3, which is 2. And then when you plug in negative 1 here, what do we get? We get 1. And then minus 2 minus 2. Okay, so maybe I should write this as minus 1 plus 2. So how about if I erase this? Let me write minus 1 plus 2. So this is minus 1 plus 3. So when you plug it, you get this. And so what is that? Well, let's simplify this. This is going to be 2 over, and then 3, minus 3, 3. And we can put the minus in front of it. Oh, it looks like we get this. We get a nice number. Note that we get a nice number, a negative 2 over 3. We don't get 0 over 0. So we are not getting anything which we don't understand. A 0 over 0 is something we don't understand. So that's why we cannot plug in. We have to wait. So that is the end of example 3. The final answer is is minus 2 over 3. So if you use a calculator, then you might see the number minus 0.66 or 666. But you don't know whether it's really minus 0.66 or whether it's something like that. But this is a minus 2/3. And of course, the graphing calculator does not show you any work. On the test, you must show your work. You must show your work mathematically. So therefore, calculator will not do here. Okay? Calculator will not do. Should not use a calculator on these limit problems. For evaluating limits, for evaluating limits, do not use calculator. All right. Oh, let me write this in the blue. Okay. All right. So any questions here? No question.
So just to confirm, with limits, what we do is we plug in the value that we're given. So, for example, in example 3, we plug in negative 1. We confirm it's 0 over 0. Then we rewrite the equation until when we plug in this case, negative 1, and it will show us what the answer is.
Right. Basically, when you get an indeterminate form, by the way, we still have an hour to go. The rest of the hour we'll be talking about the indeterminate forms, okay? So the indeterminate form is not over. This is the whole topic for the rest of the class. So basically, when you plug in this value, x equals negative 1, then we get 0 over 0. 0 over 0 is something we don't understand. So that means we cannot do it. We don't know what the value is. But the question is, as x is approaching negative 1, what is this argument, function approaching? And so it turns out that when you change the form, and one of the techniques for evaluating limits for polynomials and rational functions is by factoring. So example 1, 2, 3,